Good day, Doctor. We are from Group 15, Section 1 and 2. Today, we would like to propose an innovation relevant to electronic field to achieve SDG 6, which is the clean water and sanitation. Our innovation is by having a smart water quality monitoring system. SDG 6 is actually aims to ensure safe drinking water and sanitation for all, emphasizing the sustainable water management, wastewater treatment, ecosystem protection, and supportive policies. So today we would like to focus on the water management at the rural areas. So our pioneer statement is based or supported by a case study water quality issues in Langkawi reported by the popular news in Malaysia, the Straits Times. So the Straits Times reported that the residents in small villages and Kwa, which is the Langkawi's largest town, have faced murky and unsafe water supplies. And the local hotels are also forced to invest in water filters to ensure safety of the guests, revealing the inadequate public water filtration systems. So one of the local hotel in Langkawi, which is Frangipani Langkawi Resort and Spa, have stated that they have started to face the problem with water in 2024 and they have a lot of yellowish water. So according to the issues, the problem is they are having outdated monitoring systems. Besides, they are also forced to invest in high budget water filters. Hotels is fine with the high budget. However, for the residents in rural areas, they are not able to afford such expensive water filters. Thus, these water quality issues in Langkawi have a severe and significant impact on the small villages. Hence, our identify issues in the rural Malaysia or focus on the villages is that they are having poor water quality, whereby the water have unsafe pH levels, high turbidity, and low dissolved oxygens. Moreover, they are also lack of affordable and real-time monitoring systems. Thus, relevant to the electronic engineering field, we have developed or we have proposed an innovation of smart water quality monitoring system to achieve SDG 6 and ensure the clean water availability in the rural areas.
Next, in order to gather information and insight from the target users affected by the poor water quality and lack of real-time monitoring system in rural Malaysia, our group had conducted a short survey by using Google Form. So this survey was divided into 4 sections. And so in the first section is about access to clean water. From the result, we can see that 24 over 30 respondents said that the water quality in their rural area is not good based on what they experience. So this can be proven by the water quality rating, which is 96%, showing that most people are not happy with their water. Next, for section 2, we asked about the water contamination issues. So from the pie chart, we can see that the main problems are dirt and the color of the water. While when looking at how people will clean their water, all of them will boil their water. And about 65% of them use water dispenser and 56% use filtration system. And also some of them will use mineral water delivery service, but only a small number of people use chlorine tablets and the distillation system. So from the data, we can summarize that majority rely on boiling and filtration system to ensure safe drinking water. Next, from in section 3, we wanted to know if people would accept new technology to solve the problem of poor water. So from the result, we can see that 93% of people are interested to use a water quality monitoring device. So this means most people are willing to try new technology to get better water quality. And lastly, in section 4, we asked what features they want in the monitoring system. So from the bar chart, we got 24 people want to get notification when the water quality is not safe, and 20 people said they want have a real-time monitoring system to monitor their water quality. And also 5 people are interested in using solar power for the system. So since real-time alerts and monitoring are highly desired features, this shows that people really want to know right away when their water is not safe to use. So based on these 4 survey results, we will now look at our proposed solution, which is a smart water quality monitoring system.
Next is under me thing to propose to explain you the proposed solution of the smart water quality monitoring system. So let us roughly go through how it works. The first step is the sensor is collect the data from the water sources, and then the microcontroller process the data, and the result is displayed locally in the app or website and transmitted through the ITO to the cloud for the centralizing monitoring. And the alert will be generated if there is unsafe water conditions, and the controller send a signal to the filtration system for the water filtration. So before I explaining details about the system, let me introduce the sensor parameters that we use in our system. So we consist of 3 types of sensor parameters. The first is physical properties, such as the stability sensors and the color sensors. And the second one is chemical properties, uh, which is the pH sensor. And then the third one is microbiological properties, which is optical biosensor. So the color sensor is the sensor that determine whether there is a presence of the water contamination by the color profile. So we measure the intensity, uh, red, green, and blue light, and then determine whether the water is deviate from the neutral color profile of the sensor. So if there is deviation, means that the water is being polluted. For example, the water is polluted by the algae, the unwanted industrial discharge. So the second one is the VT sensor. The VT sensor is the sensor measure the water safety by using the luminance and visibility and measure the cloudiness of the water. So the higher the cloudiness of the water, the more the turbidity and the water being polluted. So it cannot met uh, one one or the safe water drinking standard. So the second one is the chemical, which is pH sensor. So the pH sensor, as we know, it can measure the drinking water level using the pH scale. So as we know, the drinking water, the safe water to be drinks is the pH is around the 7. So if the pH level is too low or too high, it means that it might be polluted by the acid rain or the industrial discharge. So the third one is the microbiological sensor, which is optical biosensor. So optical biosensor is to measure whether there is the presence of microbiome using light. So if there is unwanted or unideal light, means that there is a presence of the virus, uh, pathogens, and the bacteria that may be cause human to fall in sick. So now let me further explaining the water system details. So just now I already explained the sensor. As the sensor is located in the water pipeline, and then when it detect the data, when it measure the water all the time. The sensor will measure the water that flow in the water pipe all the time, and then record the data and then send to the microcontroller. The microcontroller we already set the threshold for the asset water quality levels according to the international standard for our user to know what is the standard of our water quality. So after it recorded, it will send to the cloud, upload the data to the cloud through the wireless communication modules ITO. So at the same time, the 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 alert will send to the user if there is unsafe water condition. So the user can know lah when there is present of the unsafe water condition, they can turn on the water filter system, or the water filter system will turn on automatically once it detect the unsafe water condition. So if the water quality is good, the display will display good in the website or the app, and then it store in the cloud for the convenience of the user to track back the water quality history. So this is the basic concept of our system, and then it consists few benefits. First, it can allow the user to monitor the water quality real time, and then through the affordable sensor can detect, so they can know and detect the contaminant early. And then the second one, the benefit, the user can enable self-monitoring and maintenance to promote a healthier community. So they can understand what is the water quality standard they drink usually, and then they can know how the sensor works, and then what is the standard for them to drink, what is the standard of the water for them to drink. And then the third one is about the long-term impact to the community. So when we use this system, it causes a long-term impact to improving the water quality and then support the sustainable management. So I will pass my presentation to the next person. Thank you.
Next, I am going to present our innovative solution for achieving SDGs, clean water and sanitation, which is a smart water quality monitoring system designed to transform the way rural community access and manage their water. First, let's look at how our solution addresses water quality. Our real-time monitoring system checks key parameters like pH, turbidity, and oxygen level. This affordable and easier to install sensor continuously track this indicator and send immediate alerts to community if contamination is detected, helping them to prevent health risks before they arise. Second, to ensure sustainable access, the system is powered by solar energy, making it ideal for rural areas with limited or no access to electricity. A user-friendly mobile app provides real-time updates, allowing residents to act quickly if the water quality changes. Third, real-time monitoring empowers community to take charge of the water safety. This proactive method prevents health crises and promotes sustainable water management, directly contributing to SDGs. Then, our solution also has positive impact on sustainability. Economically, our solution is cost-effective, reducing reliance on expensive bottled water and lower long-term maintenance costs due to its solar power design. It also creates local job opportunity for system maintenance and monitoring. Socially, this system empowers community to manage their own water safety. This autonomy increases awareness about water safety, directly reduces the spread of waterborne diseases, and improves overall public health. Environmentally, the system protects ecosystem by detecting contamination early and preventing water waste. Its solar power operation minimizes dependence on non-renewable energy, reducing the environmental footprint and protecting a cleaner planet. In conclusion, our smart water quality monitoring system offers a comprehensive solution that ensures safe, clean water access, drive economic growth, empower communities, and protect the environment. This benefit directly support SDGs. That's all from our group. Thank you.